Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 3. Today we're going to start with our very first section, and we're going to talk about intervals of increase and decrease. So remember, we've been talking about derivative in Chapter 2, and so this chapter we're going to be looking at the applications of derivatives. Why are they important? And the first thing we're going to explore is that the first derivative tells us about intervals of increase and decrease. So if the first derivative is greater than 0, then it's increasing. If the first derivative is less than 0, it's decreasing. So we're going to take the derivative and set it equal to 0. So again, here's a little diagram. If the first derivative is less than 0, then it's decreasing and then increasing in this area between these x values. All right. If the first derivative is 0, that means the slope is 0, then that could either happen at a max or it could happen at a minimum of the function. So we're going to be exploring these different options. So again, intervals of increase and decrease, and again, there's a lot of slides here. You're welcome to go to Blackboard and read through these. I'm going to continue moving on. Again, first derivative is greater than 0, it's increasing. Less than 0, it's decreasing. If it's equal to 0, then it's a constant function. The slope is 0. Here we go. First example. Here's the function. We're going to find the derivative, which is 2x. Set it equal to 0. 2x equals 0 when x equals 0. And so it says show that it's decreasing. So the reason that we set it equal to 0 is because we know that it was either increasing or decreasing before that. So sometimes we just go to a number line, plop down the critical values, and then we run it's called the first derivative test. And the test would say, well, check anything to the left of that, and this is called the critical value. This 0, when you take the derivative set equals 0, that's a critical value. So the test may be f prime, let's just go -1. That's to the left of 0. And then you take this and plug this into the derivative. And so 2 times -1 is truly a negative number. And because it's negative, or less than 0, then we know that this is decreasing. And then we could run a test over here. This is equal to 2. And since it's positive, then this side is increasing. And then one way to try to help us make sure that you're showing me all of the steps that I need is this chart that I've created. So we'll check the intervals from the left of the critical value and then to the right of the critical value. And the test value would be f prime -1. The sign would be less than 0, and then the conclusion is it's decreasing. F prime 1 is greater than 0. And so then I know that it's increasing, or that I know that you know that it's increasing from 0 to infinity, and it's decreasing from here to here. Of course, you could always just go to your calculator and look at the graph of this thing, but that's not the goal. The goal is to show me that you can do the work, and you can actually determine that this function is decreasing up until the critical value of 0, and then increasing on this side. So don't cheat and use your calculator. Instead, you're going to be finding the derivatives and setting them equal to 0 to find critical values. Remember, if the slope equals 0, then that's going to create a max or min. Now, if the function is increasing on this side and then decreasing on this side, of course you've got a max. And then vice versa, if it's decreasing on this side and then increasing on this side, then you've located a minimum. So be careful here. The derivative is actually undefined because the slope is so steep when it comes. See, here's the slope, here's the slope. It's so steep that we have a vertical line, and of course that's not slope. That's no slopes. These vertical lines here do not create slopes, or sometimes it's called undefined slope. But we still have intervals of increase and decrease. So you can kind of think about the bug. You read a line like you read a book, or you read a graph like you read a book from left to right. So notice that these bugs are always heading from left to right. Yay. And oh, this could be decreasing until you hit a critical value, and then it could be decreasing some more. So don't think that because when you hit a critical value, it's got to go decrease to increase or increase to decrease. It could go, here's an example, decrease. This is a critical value. We'll find that out in a moment when we find more derivatives. So, by the way, what is critical values? Two things. It's when the derivative is equal to 0 or you have an undefined function. So you need to check both. Critical values, like, for example, if you have x minus 5 over x minus 3, then x equals 3 is going to be a critical value. You could find the derivative of this, but x is 3 is critical because that's what sets the denominator equal to 0, and of course that's going to be undefined. X equals 5 is critical. You would think it would be critical because it's an x-intercept, but you would have to find the derivative and set it equal to 0 to actually find the critical value. So it's not x-intercepts. They're not critical. It's where the derivative is equal to 0. So, example number 3. There was no example number 2. The derivative here is 6x squared minus 18x. I'll set that equal to 0 by factoring out a 6x. 6x equals 0 when x equals 0. That's critical. And x equals 3. So again, I could go to my number line, or I could create a chart here from negative infinity to the first critical value, from 0 to the next critical value, and then 3 to infinity. And then run some tests. But I don't think I need to run a test here because it just said find the critical numbers. So I think my critical numbers are 0 and 3, and I'm done. I think that's all they wanted for in this problem. I didn't have to tell me about intervals of increase and decrease. Let's try again. Sometimes the hard part here is just making sure you're finding the derivative correctly. So if you need more practice with that, go back to chapter 2. The derivative here is 3x squared minus 3x. Factor out a 3x, leaving with x minus 1. Set that equal to 0. Either x equals 0 or x equals 1. And then this actually does say intervals of increase and decrease. So if you find this chart helpful, I would encourage you to use it. Let's see if I can drag it up here a little bit closer. And so my critical values were 0 and 1. So I'll go from negative infinity up to the first critical value 0, 0 to 1, short interval, but it's critical to critical, and then 1 to infinity. You don't always go infinity and negative infinity. Sometimes if you have a function that looks like this, the square root function, it wouldn't be defined to negative infinity. But this function is a polynomial, so it is. Let's run a test value here. I'll test f prime negative 1. And when I run the test, I'll find out that it's greater than 0 or increasing. Sometimes it's nice to tell me how you know that it's greater so that I know you're not just going to your calculator and cheating. You're actually taking this guy and plugging this in here, probably the factored form. So this guy is 3 times negative 1, which is negative, and this guy is negative 1 minus 1, which is also, and negative times negative is positive. So sometimes I really like this step right here because it's kind of showing me the work that you're actually going to the derivative. If you can complete this, let's see, we got to plug in a half. So a half plugged into this guy is positive. A half plugged in here is negative, and of course that's going to be less than because a positive times a negative is negative. And then that's going to be decreasing, and then you finish this off by doing f prime 2. Doesn't matter, you could try 4, 6, or 8. But if you plug a 2 in here, that's going to be positive 6. You plug a 2 in here, and that's going to be positive. That's going to be greater than 0, and that's going to be back to increasing. So those are all of the intervals. I like the chart because it kind of just keeps your thoughts organized. Here's the author's solutions. Again, they're showing me nice work. If you just want to tell me what this value is, instead of, I was kind of just quitting and just doing this. Negative times negative is positive. If you just want to go to the function and just tell me what that answer is, this is some number. But it's nice that you're doing something, so I know you're not just going to your calculator and just looking. There's, oh, it's increasing until it gets to this max. It's decreasing until it gets to this min. That's really not the point here. Example number 5. Let's go find that derivative. Let's see. the derivative of the outside, write down the inside. Don't forget to decrease x by 1. And then the chain rule says times the derivative of the inside. So if I clean this up a little bit, it looks like I've got a 4x in the numerator and 3 times the quantity, this to the 1/3 in the denominator. So I can see I've got some critical values here. If I set this equal to 0, then 4x equals 0 when x equals 0, and the denominator equals 0 when 3 times the quantity, this to the 1/3 equals 0, and that means x squared minus 4 to the 1/3 equals 0. If I cube both sides, I still get a 0. So cube this. So when does x squared minus 4 equal 0? That's when x squared equals 4, or x is plus or minus 2. So I've got quite a few critical values here. Let's list them here. From negative infinity to negative 2, from negative 2 to 0, from 0 to 2, and then 2 to infinity. So I might not have enough space in my chart because it's a generic chart, so you just add a little bit more. So then you're going to run all your tests. The test value might be like -3, -1, 1s, and 3s. You check the signs. This is going to be less than, greater than, less than, greater than. And if this is less than, your conclusion is decrease, increase. It won't always alternate like this. Decrease, and then this is back to increase. Let's see if I did that right. Let's see what the author says here. So there's the intervals, and yep, decrease, increase, decrease, increase. Of course, looking at the graph, if you go to your calculator, it looks kind of funky. Alright, so we're looking for zeros and undefined values. If that's the first derivative. If the first derivative is undefined, then we found a critical. And before we find the derivative, you can see that this function is not continuous at x equals 0. But let's go find the derivative and then explore that I think it's going to be undefined at 0. I'm going to have to do the quotient rule. Low d high minus high d low all over low squared. I'll just write x to the 4th because x squared squared. So this is what? 4x to the 5th, because you rewrite the base and add the exponents, minus 2x to the 5th plus 2x all over x to the 4th. And I almost just made a classic mistake. So when I distribute this, I have to remember to go back and distribute this negative throughout everything. So it's actually like this. And so this is really 4x to the 5th. So 4x to the 5th, take away 2x to the 5th is 2x to the 5th, but I need to distribute this. So this is minus a 2x. All over x to the 4th. It looks like I can pull out an x at least, leaving me, oh, how about a 2x? Let's pull out a 2x, leaving me with x to the 4th minus 1, and then one of these x's will cancel. So here comes the derivative. F prime x is equal to 2 times the quantity x to the 4th minus 1 all over x cubed. So setting the numerator equal to 0, I get x to the 4th equals 1 when x is plus or minus 1, and of course this gives me x equals 0. So those are my critical values that I'm going to plug into my chart. And my intervals are then negative infinity to -1, -1 to 0, 0 to 1, and then 1 to infinity. I'll run some test numbers. I'll check -2, -1/2, 1/2, and 2. And I'll determine that the first derivative here is less than 0, greater than 0, less than, and greater, and I am alternating once again. So you're going to think that it always alternates. Well, it usually does, but I wouldn't depend upon it alternating. You need to actually run the check. One of the things that you can do is actually go through and graph it. So you can see here it's decreasing, increasing, decreasing, increasing, and you should pretty much have those critical values. The critical values at -1 and 1 are in our chart. There's our critical values of -1 and 1. What was happening at x equals 0 is kind of interesting. We have a vertical asymptote right there at x equals 0. And that's where the function was not continuous or undefined. You can kind of see that from the get-go, but we really should be reading that off of the derivative, because that's what we want to check, where the first derivative is undefined. We can't let x be 0 in that derivative. Alright, so example number 7. The only reason that this is in here is because I keep telling you you shouldn't just trust that they alternate. So maybe if we quickly find the derivative here, this is 3x squared minus 6x plus 3. We'll pull out a 3, leave me with x squared minus 2x plus 1, and maybe recognize that as x minus 1 quantity squared. And that means my critical value is x equals 1. And if I were to run a quick test and check my intervals, I'm going from -infinity to 1 and then 1 to infinity. I run some test values, find out that they're both increasing. And so you probably knew that from before we even started this, because you knew that cubic functions, or the general shape of a cubic function, hopefully you know, is in what? First and third. So it's increasing here and then increasing even more here. But this, you're just demonstrating to me through your calculus that that's actually the case. So again, here's the actual function, shifted over just a little bit. The application here that you're going to be looking at as business people is you're going to be looking at your revenue and your cost and determining profit. And by now, either before my course or from my course, you know here's a nice little definition. Profit is equal to your revenue minus your cost. And now remember, your revenue is XP, where this is a small p, where this is the price, and this is the quantity. So the directions here say find out when the profit function is increasing. Well, let's go find the profit function by taking the revenue function, 7.2, 7.2x minus 0.001x squared. Take that function and subtract off. Now I ran into this trap before, so let's make sure we put this in parentheses this time. 2.4x, or you could just change it. So it's 0.0002x squared. So there's my revenue minus my entire cost. If you simplify that, we'll come down to 4.8x minus 0.008x squared. Finding the derivative of this, well, we should just say this is the profit. So then the derivative of this is 4.8 minus 0.0016x. If I set that equal to 0, x will equal 3,000. That's my critical value. And I think that's kind of what they're looking for here. Ooh, big purple screen. Let's see if I can delete that. There it is. And good. So what does that 3,000 tell you? It's the interval. You know, if this thing starts at from these are x's to x's, not x. These are not points. So, but from 0 to 3,000, this thing is positive. Therefore, it's increasing. And then, of course, from here to here, it would be negative or decreasing. All right. So then, if you wanted to look at the function of this thing, you certainly can. That ends the video for today. I hope this lesson was helpful for you. We're going to continue our discussion with analyzing graphs through derivatives. Section 3.2. Email me with your questions. Thanks.